All right, here we go. So this is calculus application to business. So we have a couple different words that we use when we talk about business. One is revenue, which we're going to use as R of X when we write it as a function, R of X. Capital, I have all these as capitals, but you can probably do lowercase, and it's, actually, I think in the problem it's lowercase, so it doesn't really matter.
Well, I mean, yeah, radius.
They both get uppercase, lowercase sometimes. So this is how much X items brings in. Like when you're selling things, your revenue is how much you get. So this is selling the item. And this is before expenses. So it's not the profit, it's how much money you're physically bringing in. Okay. So this is X multiplied by the price per item. So X is the number of items multiplied by the price per item. Cost is going to be C of X. And that's how much it costs to make X items.
That's your notes for tonight.
That's your notes for tonight, yeah. How much it costs to make X items. The profit is P of X, and that's how much you make after expenses.
Why do they do revenue instead of gross?
I don't know. So how could we relate these three together?
X times price minus X times cost.
What if we were just using these three things?
Well then, if
P of X equals R of X minus C of X.
That.
Okay, so your maximum profit, if we think back to what we learned last unit, where do you find maximums? So the maximum profit happens where P prime of X equals 0. Because we know the property of limits, because remember your derivatives are actually limits, right? They came from limits. The property of limits says that if we have like one thing, like this is P prime of X equals 0, we can kind of relate that to subtraction as well. And so that's actually going to say that R prime of X minus C prime of X equals 0. So that's an alternate formula.
Don't you have to also make it so that
P prime of X minus R of X, R prime of X equals negative C prime of X?
You could do that, or you could also say R prime of X equals C prime of X. So your maximum profit is when your revenue and your cost are changing at the same rate, apparently.
don't you also make it so that it's double prime is less than 0?
Yeah, so you have to, you're going to want to make sure that it does the plus and then the minus, yeah. Yep. All right, so here it says a manufacturer can sell X items a week for a revenue of R of X equals 200X minus 0.01 X squared cents. So let's go ahead and write that. P of X equals 200X minus 0.01 X squared. And it costs 50X plus 20,000 cents to make X items.
Wait.
Oh, I did
R of X.
R of X. Is there a most profitable number of items to make each week? If so, find what it is. Okay, so how do we find P of X? Yeah.
Equal to each other.
Yeah, so if we want to go ahead and do it that way, and that's why they give you 3 different so I have, oh, here's a pencil. Ah! Perfect, okay. So, actually I'll write it over here. R prime of X is what?
Negative 0.02x plus 200.
Okay.
I want to put the x in front.
I got you. Minus 0.02x. You can switch the order if you want. And then your C prime of X. Okay, and so like you guys said, we can set these equal to each other.
.02x equals 150.
Right, and then you made them both positive, that's fine. Okay, yeah. So we have 2/100ths x equals 150. So we can multiply by 100 over 2, multiply by 100 over 2. X equals, yep. All right. Now, what do we need to do before we say, yep, for sure, that's the right answer?
Check it with another.
We need to check it and make sure it switches from positive to negative there, right? Okay, so we have 7,500. Now this is where we have to be careful. We're plugging numbers in, right? Like I could plug in 0 because that's easy, and then like 8,000. Where am I plugging those into? But which derivative equation?
R prime x minus
It has to be R prime x minus C prime x.
so it'd be 150
Yeah, so this is your R prime minus C prime. Okay, so if we plug in 0 right here, we have 200 minus 50 plus. If we plug in 8,000,
Very negative.
yeah, it's going to be a very negative answer. Okay, so does that confirm that we have a maximum profit? I mean, it's 8,000 divided by 100 times 2 divided by 100.
Fairly heavily negative.
Pretty
Well,
negative.
It's 1,600.
Mm-hmm. Yeah, it's pretty negative.
And then minus 50 plus 200.
Yeah.
So
Okay, so what do we say?
So that is in fact the maximum profit.
Mm-hmm. So we're going to say the most profitable number of items to make each week.
Alas, if only it were so easy to boil down profits and cost and revenue into such simple equations in real life.
Yeah,
The math,
but this is the starting point.
the math is easy. The equation building is the hard
Yeah.
part.
Anyone notice what was kind of weird about this problem?
they don't tell us what they're making.
That it's weird. There's another thing that's weird about it. It's in terms of cents. Did you guys notice that? It's not in terms of dollars, it's in terms of cents.
So
Weird.
they're making,
It's very strange.
wait, so they're making $75 a day. Gross. Oh, no,
No, that's how much items.
Yeah, I was about to say, you don't need to put.
All right, let's go to the next one. Given that the revenue is 10x and the cost is x to the third minus 6x squared plus 15x plus 5,
Oh, yeah.
is there a production level that maximizes profit? If so, what is it? This time we have to use a different formula than we used last time because we got to practice. So do you guys want to find P of x or do you want to do R minus C? They're basically the same. Let's do P of x. So we're going to say P, it is, but we're going to do it in a slightly different order. So P of x is R minus C I know, I'm making you guys do it a different way. I know. But the process feels different, yeah. Don't make me throw you out. Don't make me throw you out, Toby, because I will. I will. All right. So we've got 10x minus x to the third plus 6x squared minus 15x minus 5. So what do we have?
You have negative x to the third plus 6x squared minus 5x squared.
Okay. And what do we do next?
You find the derivative.
Find the derivative. So p prime of x is
Negative 3x squared plus 12x minus 5.
Oh, I was talking about the derivative. Oh, yes. Yeah, no. Right.
okay.
And then you set that equals 0.
How are you going to multiply the -5 and add to 12?
And can we move everything? Can we switch sides
Yeah,
of everything?
Yeah. So 3x squared minus 12x plus 5. You guys need to whisper better. All right, so we are asking ourselves if we're going to factor this. We're saying, can it multiply to positive 15, but add to negative 12?
But you didn't add the 1 on the 15. Wait, why'd you write it positive? Oh, you switched it. Okay.
You guys were talking, so you missed that part. So can we factor this? No. So what do we have to do instead? Quadratic formula. Okay. So x equals, so 12 plus or minus
What if I've done negative sign, we could factor it. Oh, well.
84. Do we know how to simplify that?
You could start seeing what you can take out of that. You can definitely take a 4 out.
4 times
4 times 21. Minus 3, but there's no.
So 2 plus minus 2 square root 21. These are the fun moments where we're just like nitpicking the algebra. So what does it become?
Negative 6 plus or minus.
Wait, 6?
21 over 3.
6 plus or minus.
Oh, divided by 2. Yeah, 6 plus or minus root 21 over 3. Okay, so for us to be able to do a sign chart, we are going to have to plug that in a calculator most likely. So we've got the negative version, and we have the positive version. Infinity over there. All right, so let's go ahead and, I mean, we could kind of figure out what this would be. What number would definitely be smaller than this? Root 21 is close to root 25, right? So 6 minus 5 So 1/3 is definitely smaller than that, right? Because root 25 is taking away more. Do we agree with that? Okay.
Why couldn't we just say 0?
Oh, you can plug 0 in, yeah. That's fine.
Plug infinity in?
No, but you could plug in like 100. 100's probably bigger than this. So I guess really the trick is we got to find something that's in between. So, yeah, because we know that 1/3 was slightly smaller, so 1. Okay, so the 1/3,
Almost 2/3.
or 0, let's plug in 0. So 0 would be 5, so that's positive. You know what I just realized though? We have to go back to our original. We have to go to this one. 0 would be negative because we changed the sign of it to solve it. We have to go to this one. We got rid of the negative one we had factored out in the front. Yeah. All right, and then if we plug in 1, what do we get?
Oh, that's why you.
Yeah.
I just.
Wow,
Like,
Wolf, it's amazing.
So if we plug in a 1, it's positive. If we plug in a million, very negative. All right. So what production level maximizes profit?
plus 21/3.
That would be like the ultimate math nerd answer.
How many of these products do you
yeah.
need per day?
6 plus root 21/3.
Times 1,000.
Which
These
is
are
like-
thousands of products.
Which is like just under 2.
Okay, so let's go ahead and grab a calculator, type that in.
That'd be something like.
Okay, so what was it?
It's
Thank you.
3.53.
3.5. Let's do 3 decimal places.
3.528.
Okay. And this was in thousands of units. So we can say the production level is maximized when we have 3.528 thousand units. Or you can move your decimal place over 3 times and say that many units. Okay? Yeah. But that's not a normal math rule, so I'm not going to say that. Right?
Here's a new math rule. When you're rounding to 3 decimals and you multiply by 1,000.
Yeah. That sounds complicated. The production level that maximizes profit is 3.528 thousand units. Okay. And now, after all of that, you can officially do number 16. And that's all. So that's cool. So basically, if you guys notice this, these questions are not difficult, right? The only thing you need to take away from this is that P of X is R minus C, and the maximum profit is at P prime. That's all you have to take away from this, okay? Because mathematically speaking, these are pretty simple,
Is that
I
right?
guess if there's no P prime equals D.
P prime is 0.
P prime not be D&E because it's not. There's no. Couldn't it?
I mean, most places are going to have a maximum profit.
No, that's not what I meant. I mean, would the maximum profit also because that D&E is also a critical. D&E are also critical points. So could you also have a?
Yeah, depending on the function, yeah.
Yeah. Okay.
Yeah.
I was just double checking because you said 0 specifically, so I wasn't sure if you were.
This